Hey mathematicians, here are your notes for 8.6, talking about solving rational equations and inequalities. So, to do so, we need to know that a rational equation contains one or more rational expressions. And we can solve these one of two ways. The first one is by multiplying each side by the LCD to knock out those denominators. The second one is just by simplifying one side so that it's all one fraction and then cross-multiplying. I personally prefer the first method, but the big thing is no matter which method you use, we have to make sure that we state any excluded values that are going to break our fractions or cause them to be undefined. So if we go ahead and look at this first one, my first thought is that the LCD of 2 and 3 is 6. So I'm going to multiply the entire left side by 6. But what I do to one side, I have to do to the other to keep it balanced. Now when I multiply this in and distribute, I get 6x divided by 2, which is just 3x. When I distribute there, I get 12x divided by 3, which is just 4x. 7 times 6 is just 42. And now we can simplify as we're used to doing. Divide both sides by 7. I get that x is equal to 6. Now, if you don't like that method, we can go ahead and get a common denominator instead. Still 6, so I'm going to multiply the left fraction by 3. I get 3x over 6. Multiply the right fraction by 2. I get 4x over 6 equal to 7. This becomes 7x over 6 equal to 7. And when I cross multiply and solve, notice I get the same answer. There wasn't a variable in either of my denominators, so there is no excluded values for this one. However, let's go ahead and look at the next one. 9/10 plus 2 divided by x plus 1 equals 2/5. My least common denominator would be 10 times x plus 1. So I'm going to go ahead and multiply by that on both sides. All right, when we do this, when I distribute it here, the 10s are going to cancel. So I'm going to have 9 times the quantity x plus 1. I'm going to go ahead right away and just not write that denominator anymore. When I distribute it to the second term, the x plus 1s are going to reduce, so I'm just going to have 2 times 10. And then on the right side, I'm going to have the 10 and the 5 are going to reduce to 2, so I'm going to have 2 times x minus 1, which is just 4 times x minus 1. Now we can do a little bit of simplification. 9x plus 9 plus 20 equals 4x minus 4. Put all that information together, you're going to get that 5x is equal to negative 25 and x equals negative 5. However, since we did originally have a variable in our denominator, I have to find my excluded value. X plus 1, set it equal to 0. I find that x cannot be equal to negative 1. So my answer is x equals negative 5 with an excluded value of negative 1. All right, second page, same thing. I'm going to go ahead and keep using the method of multiplying by that LCD. If you'd like to see the other method, definitely come see me. I would be more than happy to help. Right off the bat, I see that my excluded value for this one is going to be the same for this one because it's just multiplied by a factor of 2. So in this case, when I set 2r plus 1 equal to 0, I get that r cannot be equal to negative 1/2. Now let's go ahead and do some multiplication. The LCD of 2r plus 1 and that, I'm sorry, not 2r plus 1, the 4r plus 2 and the 3 would be 3 and 2r plus 1. with that 2. So I'm going to multiply both sides by 6 times 2r plus 1. Oop, too many parentheses. All right, times r plus 2 divided by 2r plus 1. Trying to figure out where to put my parentheses. Thanks for your patience. R divided by 3 plus 3, and I'm going to factor that in the process to 2r plus 1. All right, so when I multiply that in, I'm going to get 6 times r plus 2, because the 2r plus 1 on bottom canceled, equals, let's clean that up a little bit, shall we? All right, 2r times 2r plus 1 plus 3 times 3. And then we do a little bit of simplification. 6r plus 12 equals 4r squared plus 2r plus 9. When we subtract those over, we're going to have to FOIL, or factor. We'll get 4r squared minus 4r minus 3. I can factor that into 2r minus 3 times 2r plus 1 and get that r is equal to 3/2 and -1/2. However, if you look back at the very beginning, we determined that our excluded value was -1/2. So we can go ahead and say that this is not a viable answer and cross it out. I do want you to be able to find both values on a test, but I also want you to be able to identify that some answers are not possible and they're not answers that we like. All right, let's jump over to B here. If you want to pause the video and try the next two on your own, I highly encourage you to do so now. Otherwise, we're going to go through it. I want to factor this big quadratic function on the left-hand side to see what I'm working with first. I'm lucky that when I do that, I see that it's plus 4 and minus 2, which is what I've already got going on over here. So when I multiply both sides by that, it's just going to cancel out the denominator of that first big fraction. So let's multiply everybody by that. I don't really want to copy that all in, but I'm going to. Multiplied it there, we're just going to get 3x. When I multiply it over here, the x minus 2 is going to cancel, and the x plus 4 is going to cancel here. So I get 3x equals x plus 4 times 1 is all that's left. So I don't have to write times 1. And then the x plus 4 cancels here, so I'm going to have plus x times x minus 2. All right, simplify it out. We've got x squared minus 2x. And then I'm going to subtract that 3x over. So I end up getting 0 equals x squared minus 4x plus 4. When I factor that, I get that it's x minus 2 times x minus 2. And my answer is 2. However, I want to go back up and check my excluded values. It's not going to be equal to 2, and it's also not going to be equal to -4. Now, how is it possible that I get a solution that also happens to be one of my excluded values? Well, sometimes that happens, in which case this would be one that has no solution, because the solution that we got is not one that is viable. So we just write no solution. All right, let's check out that last one. Notice it doesn't matter when I find the excluded value as long as I don't forget to find it. For this first one, let's find the excluded values. X cannot be equal to 2 or -1. I personally like finding them first, that way I don't forget about them. The LCD is going to be those two things multiplied by each other, When I multiply that by the first thing, the x minus 2 cancels, and I just get 4 times x plus 1. When I multiply it by the second, the x plus 1 cancels, so I'm left with x minus 6 times x minus 2. Nothing cancels on the right-hand side, so I'm just left with the whole thing multiplied by itself. Go ahead, FOIL all that out. It's going to be kind of gross, but we can do this. Let's do negative x squared. That would be negative 8x, so positive 8x. Positive 12 would be negative 12 equals x squared minus x minus 2. Put it all back together. I get 0 equals 2x squared minus x minus 18. Unfortunately for us, we can't factor that. It doesn't factor, so we have to use the quadratic formula. Yes, that is coming back. We do have to remember how to use that. So, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When I go ahead and simplify this, I get 1 plus or minus the square root of 145 divided by 4. And I can't simplify that any further. It also doesn't conflict with my two excluding values, which were 2 and negative 1. Notice at the bottom here, it does say we can use a graphing calculator to check these answers, but it doesn't give answers in root form. And then this shows you how to do that on your graphing calculator. If you're interested in seeing that in person or finding that program that will help you find the Polyroot Finder, I would be more than happy to help you out. This has been a lot. You've done great with it. Let me know if you have any questions.